Okay, all right. Let's start today. Okay. So this will be the last class before the break, right? We have no class next week, just as an announcement. All right. Okay. So we have a mathematical model of the underlying mechanisms. Okay. So this doesn't really start from established economic theory. The structural estimations start from established economic theory, use it, fit it to data, and treat it really, really seriously. So we saw an example of auction, right? And on the auction example, the structural model or economic theory performs really well. Because why? Because here the model is sort of like the correct model to describe the situation. Now, whether the structural model performs well or not depends highly on whether the model is good or not, right? So if your model is good, if your theory is good, then that's great, okay? Then your structural estimation, if done well, could give you really strong results and predictions. Now, on the other hand, if your model is bad, then oftentimes it will give you really bad results. So that's really, so for that reason, and like I said, in economics, our models, economic theory has not been far from the precision of natural science models, right? So in natural science, in physics, for example, that everybody does so-called structural estimation because they always fit their quantum mechanics models, the relativity models, right, to the data they observe. So they always do structural, right? They very seldomly do you see any people doing reduced form because they really believe in their model. Now, economics, our model oftentimes is not that great. So sometimes if you think your model describes the data well, you can use it. If there's no good model, oftentimes it's better to use reduced form, right? So we'll talk more about this later in this course. But here's another example that's just to showcase you what the structural model can do and the structural estimation, what kind of results it can give us. So here are some data about a company. This company has a lot of market power. So you can think about it as almost like a monopoly. So as a company has a lot of market power. Now, if a company has a lot of market power, what that means is this company has price setting power, right? So in different market, the company can set different prices. So these are observations of different markets. Each little dot is a different market. Now in this market, here on the y-axis, it's sales divided per person sales divided by population, and on here it's price. Okay, so the higher you can see that it looks like we have an inverse relationship, right? So the higher the price, the less the sales you get. Right? So it seems like a demand curve, right? Looks like a demand curve, something like that, right? Okay, now except that this company is not a company in a competitive market. It's a company that has a lot of market power. So let's think about what kind of model, economic theory, can be used to describe this kind of data. Right? Now, what we can use is a monopoly model. Right? So everybody who has learned the basics of firm industrial organization and firm behavior has the basic economic model that we use to describe monopolies. Okay. So what we can do is, if we really want to use economic model or theory, what we can do is this. We can assume that there is underlying in each market, we can assume there is underlying demand curve. So the demand curve like this, okay? Underlying. Now, and the demand curve could be a positive relationship with the income and a negative relationship with the price. By the way, here we have different colors. Now, this color means high income. This color is sort of like a medium income. This color is lower income, right? We divide into 3 times. So it's almost like we can see 3 demand curve almost, except they're not really demand curve, but you can see the trend, right? Okay. So in economics, how do monopoly determine their price? And then what are the sales number as a result? If you really want to treat theory seriously, then again, back to your very, very basic economics, how does monopoly decide its price? Suppose this is demand curve, right? Suppose this is demand curve. Let's say this is demand curve of a single market, because each one is a different market, right? Each one is a different location. Suppose we are the demand curve of the nth market, small market. Now, suppose this is the cost curve of a company. The cost curve. Right? Now, the more you produce, the more cost, the higher the marginal cost. Right? So this is the marginal cost of the company. And how does a monopoly decide its price? Do people remember? Now to draw the graph, there's a marginal revenue, right? And this is how much the monopoly will produce, correct? and go up, up, up. This is the price that the monopoly will set. Okay? That's economic theory, right? It's very simple. If you remember from your basic economics, that's an extremely simple story about how monopoly decides the price. Now, what we're going to do here is we're going to treat this theory very, very seriously. And then we're going to fit this theory to the data. Okay? So this theory is not just some theory you read in textbooks, and then when you do data analysis, you never use the theory. We're going to use this theory to describe the data we see here. In particular, we're going to say that there is a demand curve. Right? We're going to say the demand curve looks like this. It's a relation with income and the price. The higher the price, the lower demand. The higher the income, the more demand. Right? Typical demand curve. Now, given this demand curve, what this company would do is that it will maximize its profit. Okay? And the profit, how much is the profit? The profit is the price, right, times the quantity, but the quantity is a function of the price. Basically, this is the demand curve that the company faces, right? And then it's going to minus the cost, sorry, minus the cost of producing a certain quantity. Okay? Again, the quantity is a function of price. Okay. And then I'm going to, so the monopoly will choose the optimal price. So the price that we really observe is the result of maximizing, right? Is the result of maximizing this. So how do we maximize this? Take a derivative, right? Okay? So everybody learned that. With respect to P, so this is Q, Q is the price of P plus, okay, plus Q prime. Sorry, right? So P times Q prime. P and minus C prime Q, right? So you get it. Okay. And then if you solve it equal to 0, right? Equal to 0. If you solve it, then what is the relationship? By the way, can I turn on the lights here? Is it better? It's better for me. So, okay, so if you really solve it, then what you get is the marginal cost at the optimal point. The marginal cost is P plus Q divided by Q prime P. Okay, right? So that's the pricing formula for the for monopoly. Okay? So this is a solution to this problem. Now behold, what happens here is this P is the optimal P. Now we assume it's the optimal price. This Q is the quantity, is the sales at this optimal price. Now I'm going to say right now that this optimal price is indeed the price we observe in the data. Okay? I'm going to assume that each price here is an optimal price set by the monopoly. So this price we already observe. It's in our data. I'm also going to say, okay, this Q is the sales at the optimal price, which will be something like this, right? Okay, or not? In other words, this is observed, this is observed, this is observed. So everything here is observed, which means I can get C prime Q. Right? And the C prime Q is what? Is the marginal cost curve, correct? This is the marginal cost. So if I really believe in this theory, then from my data on price and the sales and the income, I can basically deduce the cost of this company. The entire marginal cost curve, I can calculate it. And then once I know the marginal cost curve of the company, I can use it to do any kind of thing, right? So I can use to predict firm behavior in various different settings. And that is the power of believing the economic theory, correct? So here's what I did. This is the result. Now this red curve is the estimated demand curve of a single market. Remember, here we have many markets. I basically choose one of the market. I choose one of the market in the middle. It's a median income market. I estimate the demand curve. It looks like this. Okay? And this blue curve is my estimated marginal cost curve. Okay? So this is the blue curve. Is this the marginal cost curve? So this is all what I estimate from the data we were given, using the methods that I just described. It's very easy. Take the P, take the Q, calculate the marginal cost, and there we go. Okay? Now, in this particular market, remember this is just one of the market. In this particular market, here you can see that because in our data we see what are the sales number in this market. So this is the sales number. Okay? So this is it. And this just looks like textbook model, right? Because this is the marginal cost. This is demand curve. In a competitive market, this is where the firm should produce, correct? But because it's a monopoly, it produces here, right? So that's the, so presumably this is the marginal revenue, and this is the point where it should really produce, and this is where the price truly is, okay? Produces less than the competitive market point. So what can I do with this result? Well, for one thing, the first thing I can do with this result is something that you will never be able to do if you do not use theory, if you do not do structural estimation. The first thing I can do is do a normative analysis of welfare. Remember in your econ class, right, when you study economic theory, you always do, at the beginning, you always do a lot of welfare analysis, consumer surplus, producer surplus, total welfare. How do we do this in reality? Using data. Okay, if I want to ask you to, suppose I am for example, suppose I'm the government, I'm interested in antitrust. Okay? Antitrust is a huge issue today, especially with regarding to internet companies and platform companies. There's a lot of regulation going on how to regulate near monopoly behavior for large Silicon Valley firms today, right? Now, suppose I'm the government and I'm interested in, or I'm the court, and I'm sort of going over a case involving antitrust case. I want to estimate the loss of welfare due to a monopoly. How do I estimate? Well, if you do this job, you have to go out and collect data on firm behavior, and you have to estimate the loss of welfare due to monopoly behavior. So you have to do this from data. How do you do that? This is one way to do it. Okay? This is one way to do it. You get this data, and you calculate the marginal cost. You estimate all these things, and you say, look, the loss of welfare, which is the deadweight loss, right, is this little triangle, correct? So this is from your textbook. It's very easy. So, and once you have this curve, and you know this is how much the firm sells, this is the deadweight loss you have all learned in your basic textbooks, and you can calculate it and can quantify it. And then you can send it to the court or the government and say, this is my estimate of the welfare loss due to the monopoly behavior, and then people can consider legislation and other things, okay, in legal battles. So this is the power of structural models, which allows you to estimate these underlying hidden latent variables like cost, and allow you to do normative welfare analysis, which we'll never be able to do if you do not use theory, right? Now there's other things you can do, which is once you have an estimated structural model, you can use it to do something called a counterfactual simulation. Okay. Now the graph is stupid, but the idea of counterfactual simulation is that you can use the estimate model to predict what would happen when that thing has never happened in history before, at least not in your data. So, for example, let's suppose my question is, what if the government imposed a 20% sales tax on this company, or at least on this market, for example? What happens? Let's suppose now that there is no sales tax. Before this, there has been no sales tax, and the government says, okay, I'm considering a 20% sales tax. What will be the result? Now let's come back to the data. This is all the data you have, right? Price, sales, income, population. This is all the data you have. Based on this data, can you predict what happens if there's a 20% sales tax? What happens to price? What happens to sales? Can you do that? If you do not use structural estimation, probably there's no way to do it. Think about it, okay? If you do not use structural estimation, how do you answer this question? 20% sales tax. Now, this 20% sales tax has never happened in this supposed country before. Now, if it has happened before, let's actually think about it, right? If I use reduced form, if I do not use structural estimation, how do I estimate the impact of 20% sales tax? Now, one way, at least for lots of you who has done economic analysis, if I ask you this question, you're probably the first intuition, the first method you can think about is probably go and collect data on different sales tax and then different results, right? Different price and different sales as a result, right? So you want your data to be like this. So you want your data to be like if the sales tax, historically, if you observe sales tax 10%, what happens to price? What happens to price? What happens to sales, right? And then you go to another location, maybe another country, maybe another time period, you see people doing 5% sales tax, and then you say, okay, what happens to P, what happens to Q? And then, so you would need to collect a huge number of different areas and different times where people have tried a different number of different level of sales tax, and you want to observe their resulting P and a Q, and then you just run a regression, correct? That's what you do if you use reduced form approach. You do not use structural. Now, if you want to run a regression like this, the prerequisite, at least, at the very minimum, you need data on historical sales tax, different levels of sales tax in different places. You need that. If we use structural estimation, we don't need it. I don't need to observe historical sales tax. I can predict what would happen even if that event has never happened in my data before. So in my data, I do not observe any sales tax, zero sales tax. But I will be able to predict what happens when there is a 20% sales tax. That's called a counterfactual, in a sense that it has never happened before. Counterfactual, okay? Not facts. Right. How do I do it? It's extremely simple. According to my theory, I've already estimated the cost curve of this company. And I know the demand curve. So what is 20% sales tax? It basically decreased my marginal revenue by 20%, right? It's that simple, right? So this is my demand curve. This is my cost. My cost is not changed by the sales tax. This is my marginal revenue. Now, if there's a certain percent of sales tax, then the marginal revenue will decrease, correct? So there's a new equity. So there's a new optimal point, and there's a new optimal price, and that's it. That's my prediction. New quantity, new price in all different kinds of markets, and then I completely solve the problem, right? Because according to this theory, I have everything I need. I have the cost, I have the demand. Then of course I can predict what happens when you change the setting, when you give a 20% sales tax, whatever. I can predict the results. Right. And in fact, this is what the results are. So I can calculate it after tax. I've not really plotted the new price and the quantity. I have not really shown here, right? But I did a welfare calculation, because once you predict the new quantity and price, you can do welfare calculation and then compare how much consumer welfare has changed before and after tax. Right, so here I showed you that the consumer surplus will be minus 27%, total surplus will be minus 27%. Right, so what does that mean? It means that according to my prediction, because after the tax, obviously, what happens will be that the monopoly will decrease the quantity, right? But how much would price change? Now it turns out that part of the tax will be, anybody who has studied tax knows that part of the tax burden will be shared by the consumer, part of the tax burden will be shared by the producer, right? So in this case, how much burden is shared by consumer, how much burden is shared by producer? It's very obvious that consumer almost shares the entirety of the burden, right? So the entire decrease in total surplus almost goes to consumer surplus. Is that reasonable? Is that to be expected? Yes, because here the monopoly, because the producer is a monopoly. So it's a huge market power to transfer the burden, tax burden, to the consumer, right? So this is a very reasonable result. That when you tax the monopoly, a lot of tax burden will be transferred to the consumer in the sense of rising price after tax. Okay? Right. So this is what you can do with structural estimation. You can do welfare analysis, you can do counterfactual simulation, which you will not be able to do if you do not believe in the theory. On the other hand, so I said a lot about the success of structural estimation, but let me just repeat again. Whether the structural estimation is good or not depends on whether the model is good or not. So let's come back to this data, right? How much, if in reality, when you observe, first of all, in reality, there are almost no pure monopoly companies. Okay, most markets dominated by large companies. They're not exactly a monopoly. Second, you really have to believe that companies are pricing the pricing behavior is described by this maximization procedure. Okay, you really have to believe that the product price that you observe in reality from supermarkets and for other places are the result of this company meticulously optimizing their profit function. You have to believe that. Otherwise, the data do not conform to the model. Right? So this is a very strong assumption to use. Okay? So again, if you're comfortable with this strong assumption, then you can use the structural model to give you very strong results. If you're not comfortable, you think that no way describes reality, then probably the model is not good for you, right? Then we should think about not using the model at all. So that's really the trade-off here. And finally, one of the final things about structural estimation is that if our model is really successful, then it has the additional benefit of being able to being able to be learned from many heterogeneous data, very different kind of data sets. So typically, remember, when we're not doing structural estimation, the typical approach, reduced form approach, is give you a data set, give you one data set, you run one regression. Give you another data set, you have to run the same regression again, and give you kind of different results. Right? Give you another data set, you run. So each independent data set, you run a regression and get some results. Especially if your data is completely different kind of data, involving different variables and other things. Right? In structural model, because its underlying theory is supposed to explain all kinds of different behavior. So a really successful structural model, you can learn it or you can fit it using all kinds of different data. And so potentially it should be much more powerful. Right? Now, example being, in physics, right, you can use the data of apple falling from a tree, right? And you test this acceleration and speed. The data from apple falling on a tree and the data of Earth orbiting around the sun can both inform you of the gravitational constant, correct? They are completely different data. But you can use either data to estimate the gravitational constant because a model describes all. In economics, suppose if we believe that individual risk aversion regulates many different kinds of behavior, from our career choice to our investment behavior, right, to when we participate in gambling or purchasing lotteries, what our choices are, then you can use a person's career choice and you can use a person's investment behavior to both estimate his risk aversion. Okay, so these are completely different data, but they can both inform the same underlying structural or theoretical constant. And that will make this theory much more powerful in the sense that its parameters can be learned from all kinds of different data so that it can potentially be more precise and give you better prediction in all kinds of settings. Now, of course, right, that all depends on whether you do have such a successful model or not. Okay, again, in physics we have, in econ so far, maybe not. Right? So that remains a point I want to make about structural estimation. Okay, so that's it, right? That's basically the plan of this course. That we are dividing our course into mainly two parts. The first part is called statistical learning or statistical modeling, where we're going to discuss very soon, in 5 minutes. We're going to start discussing how do we find the best statistical model to fit our purpose in data modeling. The second part is causal inference, where we're going to talk about how to find out the causal effect and the causal mechanism governing different variables. And in causal inference, we will have two approaches. And one approach is reduced form, and the other approach is structural. Now, we spend the majority of this course on reduced form approach. And then if we have time, I will discuss again the structural approach in a little bit more detail than we have done today, okay, in our little introduction. That's the plan. All right.